Have you ever wondered what the world is really made of? We're used to solid tables, bright light, understandable laws of physics. But what if I told you that's all just the tip of the iceberg? That at the deepest level, reality behaves so strangely. It's almost like magic. Particles that can be in two places at once. Objects that change just by looking at them. Instant connection across the universe. This isn't science fiction. It's quantum mechanics, the theory that underpins our smartphones, computers, lasers, but which we still can't fully understand. Today, we won't bury you in complex formulas. We're going to talk about 5 fundamental quantum phenomena that still leave scientists baffled. 5 mysteries with no universally accepted answer. Prepare to be amazed. Right then, let's imagine for a second. Take any object, this pen, for example. It's made of molecules, which are made of atoms. An atom is a nucleus with electrons around it. And down here, at the level of these electrons, photons, quarks, a completely different world begins. The rules we're used to, like how billiard balls fly along predictable paths, simply stop working down there. Particles behave, well, let's just say, in a rather uncertain way. They can be here and there. They can act like a solid little ball, or they can act like a wave on water. We've learned to describe this behavior with incredible accuracy, to create technology based on it. But the question, why is the world like this, remains wide open. And the first mystery is the very foundation of this strangeness. Number 5. Superposition and duality. Sounds complicated? Let me explain. Imagine you toss a coin. While it's in the air, what is it? Heads? Tails? Neither. It's in a state of both heads and tails at the same time. That's superposition in the quantum world. An electron, before you look at it, can be in many places at once, spinning in different directions at once, all at the same time. And now, duality. That very same electron can be a tiny point, a particle, or it can be a spread-out wave. The famous double-slit experiment proves this. We fire electrons at a screen with 2 slits. If we don't watch which slit each electron goes through, they behave like waves, passing through both slits at once and create a pattern of stripes on the final screen, just like water waves. But the moment we put a guard, a detector, by the slits to find out the path of each electron, they immediately start behaving like particles, flying strictly through one slit, and no wave pattern at all. It's as if the particle knows it's being watched and changes its behavior. Why can it be everything at once? And why does our look, our measurement, force it to choose just one state? What even counts as measurement? Where is the boundary between the quantum all at once and our either-or? No answer. Number 4. Quantum tunneling. Imagine rolling a ball towards a small hill. If the ball doesn't have enough speed, it'll just roll back down, right? It can't get over the hill. That's our normal world. Now, the quantum world. An electron approaches an energy barrier, like that hill. It doesn't have enough energy to get over it. But there's a chance it will simply appear on the other side of the barrier. Instantly, as if it walked through a wall. Think that's just theory? Not a bit of it. Without this walking through walls, your USB sticks wouldn't work. Even the sun couldn't shine. Particles in its core tunnel through the repulsion barrier to kickstart nuclear fusion. We literally exist thanks to this effect. We know how to calculate and use this. But how does the particle do it? It doesn't fly through the barrier. It just vanishes from one side and appears on the other. Does it take any time? It seems not. What happens to it inside the barrier? How is this possible? Another quantum mystery. Number 3. A phenomenon Einstein himself disliked, calling it spooky action at a distance. Quantum entanglement. Imagine two particles, born together and entangled. They share a past, linked by an invisible thread. Separate them to opposite ends of the galaxy, if you like. Each has a property, say, its direction of spin, its spin. Until we measure it, it's undecided. But then we measure the spin of the first particle. Say it turns out to be up. At that very instant, we know for sure that the spin of the second particle, wherever it may be, has become down. At that very instant, that's what's staggering. It happens faster than the speed of light. It's as if information is transmitted instantly, breaking the ultimate speed limit of physics. This is the basis for future quantum computers and super-secure communications. But how? How does one particle tell the other its state instantly across any distance? Are there hidden wires we don't know about? Or is our understanding of space and time fundamentally wrong? Einstein thought the theory was incomplete. Experiments confirm entanglement, but don't explain the mechanism. Truly baffling. Brain-boiling yet. We're only halfway through. The next two mysteries touch on the very nature of reality and our place in it. And the last one points to a huge gap in our understanding of the universe. Don't go anywhere. The most fascinating part is still to come. Number 2, the quantum measurement problem. We've touched on this, but it deserves special attention. This is perhaps the deepest mystery. Remember, before measurement, a quantum system is everything at once, superposition. An electron is here and there. Schrödinger's famous cat is both alive and dead at the same time in its box. But as soon as we make a measurement, open the box, look at the electron, the system chooses one specific state. The electron is here. The cat is either alive or dead. This is called the collapse of the wave function. So, does the very act of observation create reality, or at least fix it in one state? Without an observer, is there no definite world? But what exactly causes this collapse? What is measurement? Interaction with a large device, with any other atom? Is the consciousness of the observer necessary, as some thought? And where do all the other possibilities that existed before the collapse go? Do they just vanish? Or perhaps does the universe split into multiple copies at that moment, each realizing a different outcome, the many worlds interpretation? Questions, questions about the very nature of existence. And here it is, number 1, a mystery where the world of the tiniest particles collides with the vastness of the entire universe. The vacuum energy problem, or the vacuum catastrophe. Quantum theory says the vacuum isn't empty. It's a simmering soup of virtual particles, constantly popping into existence and disappearing. This activity should have an energy. Physicists know how to calculate it. Meanwhile, astronomers observe our universe is expanding, and doing so faster and faster, as if something is pushing it apart from within. This mysterious force is called dark energy. Perhaps it's a manifestation of that very vacuum energy. Its density can be measured from observations of the cosmos. And now, get this, the calculated vacuum energy from quantum theory, and the measured dark energy from observations don't match. To put it mildly, the calculated value is greater than the observed value by a factor of 10 to the power of 120. That's a 1 followed by 120 zeros. Just imagine, it is the single biggest disagreement between theory and experiment in the entire history of science. What's wrong? Our quantum theory, Einstein's theory of gravity? Or do we fundamentally misunderstand how the vacuum works and how it affects the universe? Solving this mystery is the key to understanding the cosmos. Superposition, tunneling, entanglement, measurement, vacuum energy. 5 profound mysteries that show The universe is far more wonderful and strange than we can possibly imagine. But this isn't a reason to give up. Quite the opposite. It's precisely these unsolved questions that drive science forward. Each of these mysteries is a challenge for new generations of scientists, the path to new discoveries and technologies that we can't even dream of today. Which of these quantum oddities astonished you the most? Share your thoughts in the comments. If you enjoyed this journey to the cutting edge of science, please support us with a thumbs up, subscribe to the channel, and hit the notification bell so you don't miss new videos about the most fascinating mysteries of the universe. Thank you for your time and curiosity. See you next time.